In this year's Meta Connect, they announced Llama 3.2, a set of new language models. But unlike before, Llama 3.2 is not simply a direct improvement from the 3.1 series, but rather a range of new models derived from their bigger models. This release includes 4 models, a 1B and a 3B super lightweight text-only model, and an 11B and 90B vision language model. This is Meta's first time releasing a multimodal model, specifically one with vision capabilities, and I'll get more into that later in the video because I have quite a lot that I want to talk about. So let us first look at these tiny text-only models, 1B and 3B. Their exact parameter counts are 1.24 billion and 3.24 billion. Both are pruned from Llama 3.2 8B and distilled using data synthesized by 405B. If you're curious about distillation, I talked about it previously, you can go check it out. And these two super small models also maintain a staggering 128K context window, which is something that's unheard of at this model size. But looking at its benchmarks, these two models are not like outclassing previous state-of-the-art or anything. For the 1B model's official benchmark, I have highlighted in red where it performs worse than the PHI 3.5 mini Instruct, which is 3 times its size. I think Meta wanted us to compare the 1B to the Llama 2.2B, but I decided to make this comparison for 2 reasons. First, the PHI 3.5 mini is generally better than Llama 2.2B, so it's more fun comparing upwards. And second, it'll be more obvious to see where 1B is especially good at. Like if you look at the parts where I highlighted in yellow, they are the instances where the 1B outperforms a 3B model, and it happened more often than I expected to. So if you look closely, it performs extremely well on benchmarks that evaluate long context and retrieval tasks. So with Meta stating that they are making models specifically for on-device use cases like summarization, instruction following, and rewriting tasks, with these 2 models appearing to be the first step towards that goal. Like the 1B model outperforms the PHI 3.53B model on long context information retrieval, summarization, and QA. There's even a benchmark called TLDR 9+ that focuses on summarizing social media posts, and these Llama 3.2 models are topping the chart for that, but not excluding the possibility of training on the benchmark, of course. And the 1B model do know some math, but it's not like it's super good at it. As for Llama 3.2 3B, it has around the same but improved capabilities compared to its 1B counterpart. It does, however, lose its magic as the 3B size class is a lot more competitive, where Llama 3.2 3B doesn't really stand out as much from the crowd like 1B does. But I guess no other 3B open source models support 128K tokens, and is this specifically good at performing summarization? Another major difference between 1B and 3B is that 3B seems like it is fine-tuned on tool use and 1B wasn't. So the difference in benchmark is quite big. 1B with FP16 requires 2.5 GB of VRAM and quantized with 8-bit integer requires 1.3 GB. 3B with FP16 requires 6.4 GB of VRAM and 8B quantization requires 3.4 GB. But note that I'm not including the memory which the context window will take up. And to give you some context, the latest iPhone right now has around 8 GB of VRAM, well technically shared RAM, so FP16 1B, which is the full precision, should be light work for your phone. And you can even spend compute on the context window a bit more lavishly without overworking your phone's hardware too. And if you don't know already, running models locally on your phone also provides you the best privacy. This is especially important if it is reading all your emails or messages to help you summarize or QA them. And unless you are asking it for math or homework help, you don't really need a compute-heavy model for most things you do on your phone. Anyways, now on to the other 2 models, Llama 3.2 11B and 90B Vision. These 2 are the multimodal models Meta has published that are basically LLM but include vision capabilities. Their exact parameter counts are 10.6B and 88.6B. They didn't specify which model they are based on, so my guess is that they are pruned from 70B and 405B respectively. As to why they didn't release a 405B vision model, from the information provided in the Llama 3 paper, it seems like the image encoder is too hard to train with not much improvements compared to 90B vision. So my guess is that it's kind of pointless to publish that because not a lot of people can run a 405B anyways. So these 2 Llama 3.2 vision models do also maintain the 128K context window, and on the benchmarks, they look surprisingly good. Meta has been teasing their vision model for quite a while too, with the first vision experiments being documented in their Llama 3 paper that was published back in mid-August. So I did a quick benchmark comparison between this release and the paper, and yes, I think Llama 3.2 are the exact same models that were discussed in the paper. Which brings us to the big question, are these 2 multimodal models, more specifically vision language models, models really the best open weights out there? Well, I would say not really, but let me give you some background information first. So the current multimodal LLM landscape is a bit messy. On Llama 3.2 Vision's official benchmark, they compared it to two closed source models. I think here they are using GPT-4o Mini to compare with Llama 3.2 90B and Claude 3 Haiku to compare with 11B. But the thing is, we don't even know how those two are trained, or if they are using an older model release, or completely comparing the wrong size of the models. So this benchmark is not really as clear, but I mean it generally still indicates that Llama 3.2 is slightly superior. However, wouldn't it be better to compare it to other open source VLMs, since running locally is the highlight? Not to mention Haiku and GPT-4o Mini are kind of old already. So I brought Quintao VL and NVLM together to compare with Llama 3.2 Vision, as these models are the latest talk in town. I see a lot of people throwing the phrase state of the art or the most powerful VLM around to describe these models, so let's give all of them a good look. Starting with Quintao VL, to match the size of Llama 3.2 90B, I compared Quintao VL 72B's benchmark with it. And as for Llama 3.2 11B, I compared it with Quintao VL 7B's benchmark. And surprisingly, Llama 3.2 pretty much loses across the board. However, Quintao VL doesn't have any official benchmarks on its text-only performance that is comparable with what Llama 3.2 provided. As for NVLM, unfortunately, they only have a 72B model, and I specifically compared the NVLM-D architecture variant, which is the best performing architecture out of the three which NVLM has published, and probably no longer a surprise, Llama 3.2 also lost across the board. But NVLM also doesn't have as many text-based performance benchmark either. However, I'd argue that vision capabilities are the most relevant, and I don't have the budget to run accurate benchmarks on these models, so let's just take it as it is. But to really understand the reasons behind Llama 3.2's inferiority in vision performance compared to these two, let's quickly take a look at their training and architectural differences. So in general, VLM architectures are made by taking an existing text-only LLMs and simply adding a cross-attention block within each transformer layer that connects to a vision transformer. This image transformer on the side would then process images encoded by an image encoder, which typically breaks down the image into patches and represents them as tokens. These patches are then passed through the vision transformer layers in the same way text tokens would be processed in the standard transformer, but with an addition of the cross-attention mechanism, which allows the model to combine image and text features by being able to attend to both modalities simultaneously. In Llama 3.2's case, it uses a vision transformer called VIT-H14, and to maintain the text-only performance of the Llama series while needing to train a model to work with both vision transformer and text-only transformer's attention stream, they freeze the Llama's transformer and only train the vision transformer to ensure Llama models with vision capabilities perform without any degradation in the text generation aspect. On the other hand, Quintao VL used a modified DFN VIT with a custom rope embedding they have developed to better accommodate images and used Quintao series as the base model. NVLM uses intern vision transformer and Quintao 72B instruct as vision and text LLM backbone models respectively. With both Quintao VL and NVLM, the text-only LLM is not frozen while training the VLM. On top of that, Quintao VL modded a lot of the components, resulting in their vision plus text capabilities being better than the latest state-of-the-art VLMs. So I will put them as this ranking if we evaluate them purely based on the benchmark results. But if we incorporate convenience and optimization, it might be a bit different. It's also important to note that NVLM is not instruction tuned, so if you want to use it practically, you would have to pick between Llama 3.2 or Quintao VL. For image resolution, Quintao VL uses their custom rope 2D, which technically supports any resolution. For Llama 3.2, I was able to find information on NVIDIA's Jetson AI Lab, where it works the best with images of 1120 x 1120 resolution. And when I say ecosystem, the support that already exists for Llama 3.2 is huge already. Speaking of that, NVIDIA has asked me to share with you some of their new exciting pipelines and optimizations they have made for Llama 3.2. First up is their multimodal RAG pipeline with the Llama 3.2 VL VLMs. I think we already know that VLMs are powerful for explaining images, but it gets even more convenient when the RAG system can index information based on what they see too. So if you have images, PDFs, or presentations, this multimodal RAG pipeline is much easier for you to use because you can now query depending on what you remember visually. They even have a blog about it where they go through even more examples like processing plots and charts, which is perfect for enterprises as these models can all be run locally, so you wouldn't risk any database leaks on sensitive information. The Llama 3.2 11B VLM is now supported on embedded Jetson AGX Owen 64GB, and know that you'll need a Linux workstation with an NVIDIA RTX professional GPU with 30 plus GB of memory to use the pipeline optimally. As for the Jetson AI Lab I've mentioned when I was talking about resolution, they also support download and deployment of Llama 3.2 1B and 3B. With optimized GPU inference and N4 or Flow.8 quantization you can use, along with tutorials on how you can do it, it's a breeze to get it running optimally. And the optimization ain't just tailored for Jetson AI Lab, because on release, Meta and NVIDIA work together to make sure that Llama 3.2 models are more efficient on the existing 100 million plus NVIDIA RTX PCs and workstations worldwide. And for Windows deployment, NVIDIA has optimized this suite of models to work efficiently using the Onyx Gen AI runtime with a DirectML backend. So you don't really have to worry about Llama 3.2 3B models not running smoothly on the NVIDIA RTX series. And if you're a developer but don't have the hardware, you can get free access to the NVIDIA NIM API for research, development, and testing through the NVIDIA Developer Program. And if you'd like to further explore NVIDIA's local acceleration support or API services like NVIDIA NIM, NVIDIA TensorRT LLM, NVIDIA Triton that may not be specific to Llama 3.2, you can read more about it here. I'll put all the links down in the description, go check them out, and thank you NVIDIA for partnering with me on this video. Anyways, cross-attention for VLM do feel like a hot glue solution, but I guess it's working so far. I hope we can have a more elegant solution, since if you have more than 2 modalities, cross-attention would start to get real messy. So maybe in a future video, I'll talk about some of the elegant solutions people have come up to solve multimodal models, so stay tuned. Check out my newsletter if you like the technical aspects of the VLM I've talked about today. I have already done a deep dive on VLM there where I explain the different variants and how they also ended up with using cross-attention. As for what I usually write on my newsletter, I post weekly breakdowns of the 3 must-read research papers so you can stay up to date without having to sift through archive yourself, so don't miss out. Well, technically you won't really miss out because you can just go back and look at the older issues I published. Thank you guys for watching. A big shout out to Andrew Lescelius, Chris LeDoux, Deagan, Miguilim, Robert Zawiasa, Louis Muck, Ben Shaener, and many others that support me through Patreon or YouTube. Follow my Twitter if you haven't, and I'll see y'all in the next one.